Okay, this next topic we're going to look at probability and really what probability is. A couple different examples, just a real quick explanation of that. So when we talk about the probability of an event, it's the probability of event A is the number of ways event A can occur divided by the total number of possible outcomes. So for example, a coin is tossed 3 times. What is the probability that it lands on heads exactly 1 time? So there's a couple things here. First of all, we're tossing a coin 3 times. That's my event. We want to know how many ways that can occur, and we have to divide it by the total number of outcomes. But it has to, what's probably that it lands on heads exactly 1 time? So if I toss coin 3 times, I could have heads, tails, tails, or I could have tails, heads, tails, or tails, tails, heads. So there's actually 3 ways that we could have a head exactly 1 time. Okay, we can only have 1 head when we toss the coin 3 times. But then we have to look at the total possibilities. Well, for each flip of the coin, there are 2 possibilities. So there's 2 possibilities in the first flip, there's 2 possibilities in the second, there's 2 possibilities in the third. So if I multiply those together, 2 times 2 times 2 would be 8 possibilities or possible outcomes. So when I compute my probability, I would take 3 and I would divide that by 8. So when I take the 3 and I divide that by 8, I end up with 0.375. So 0.375 is the probability that it'll land on heads exactly 1 time if I flip a coin 3 times. Okay, example 2. Here we have a jar that contains 6 red marbles and 4 black marbles. 2 marbles are drawn with replacement. Now with replacement means that I put the marbles back in after I've drawn one out. What's the probability that both of the marbles are black? Well, okay, so when we look at this, we have 6 red marbles, 4 black marbles. So when we pick the first marble, we have a chance, our chance is 4 out of 10 that the first marble would be black. And then the second one, I do it again, and that would be 4 out of 10 one more time. So technically it's like 4/10 times 4/10, and I multiply that together, I get 16, maybe 0.16, which is 1600ths. So the probability that both of them are going to be black is going to be 0.16. Notice because it's with replacement, we're still dividing by 10 even on the second marble. If it would be without replacement, then you would divide by 9 because that marble, the first marble, is no longer in the jar. Okay, let's look at the third example then. A coin is tossed and a single 6-sided die is rolled. Find the probability of landing on the head side of the coin and rolling a 3 on the die. So first of all, the probability of landing a head is going to be on a 6, landing a head on the coin is 1 out of 2, 50%, and then rolling a 3 on the die is 1 out of 6. So if I multiply those together, I get 1 out of 12. Okay, so that I can represent a probability as a fraction, or I could actually convert it to a decimal by taking 1 divided by 12, and I could write it as 0.0833 repeating, which is the same thing as 8 1/3%, because the 0.3 repeating is the same as 1/3. Okay, let's look at example 4 then. Example 4 says that we have a nationwide survey found that 72% of people in the United States like pizza. If 3 people are selected at random, what's the probability that all 3 like pizza? Okay, so when I pick the first person, the chance that he likes pizza is 72%, so 0.72. Now the second person is technically independent of the first person, so that would also be 72%. And then the third person would also be 72%. So when I compute this, all I would need to do is to take 0.72, multiply that by 0.72, and multiply that by 0.72. This gives me my final probability, which is going to be 0.3732, which is about 37.3%. So there's the decimal equivalent. The percentage chance is 37.3% chance that all three people would like pizza based upon the statistics that we were given originally. Okay, last example now. It says Mrs. Jones is deciding what to wear to school. She has 6 different pairs of shoes, 8 pairs of pants, and 14 different shirts to choose from. How many different possible outfits does she have? Well, this is a combination problem. So she had 6 pairs of shoes and 8 different pants and 14 different shirts. What you do is you basically multiply the 3 together. So you take 6 times 8, multiply that by 14, get the result, which are 672 possible outfits. Okay, you could have a problem like this with your going out to eat where you have same number, 6 different entrees, 8 different drinks, and 14 different desserts. Then you could have 672 different meals. Same type of thing. So you multiply when you have a combination problem just like this.